So this is paper 1 of the specimen papers that AQA released. We're just going to talk through the questions on this paper one by one so that we can make more sense of them. So let's get stuck in now with question 1. So question 1 is, how many centimetres are there in 3.7 metres? So for this one, there's no getting away from the fact you'll need to know that 1 metre is 100 centimetres. We just need to know that. What I'd suggest, it's the first question, it's 1 mark. Apart from knowing that, there's not much more to it. What I'd suggest is to think 3.7, that's roughly, to the nearest metre, that's about 4 metres. So if 1 metre is 100 centimetres, 4 metres is going to be 400. So we're expecting our answer to be around 400. Slightly less because 3.7 isn't quite 4. Looking at it that way, the only sensible answer we'd have would be to go for 370. To be exact, if you wanted to do it without estimation, using this conversion factor, to change from metres to centimetres, we need to multiply our value in metres by 100. So, in this case, 3.7 multiplied by 100. If you're multiplying with decimals, it's best off thinking about the number without the decimal in it at all. So think of that as 37 multiplied by 100. Just do 37 times 1 first, which is 37. Add on the 2 zeros afterwards. 2 zeros here and here. Then put the decimal back in afterwards. The number wasn't actually 37, it was 3.7. And so 3.7 has 1 decimal place, 1 number coming after the decimal in the question. So 1 number needs to come after the decimal in the answer, which should give us 370.0, which should be 370. But really, for question 1, you need to be at the point where you're thinking, I know this is straightforward. Question 2. Which of these is the net of a cube? Now, without the actual paper to hand, nets can be quite hard to illustrate. The correct answer is actually, for this one, C, which is the T-shape. Now, that might seem like a cop-out answer because I'm not really explaining it, but better than me talking about why the answer is C, I think it's probably best if I show you this video which explains fairly neatly what I'm trying to say. So if you look at this video, it's a T-shape and the net of it packs up to be a cube. So what we mean by a net of a shape is a flat pack version of a 3D object. So what might it have looked like in a factory before the cube was put together? So we can see the T-shape folds up to make a cube from that lovely diagram, which I can take no credit for. Question 3. Circle the fraction that is not equivalent to 3/8. What I'd suggest for this question is to simplify down the fractions which we have been given. So the first one, 6 over 16, 6 is even and 16 is even. So we can divide the top and bottom by 2. Half of 6 is 3, half of 16 is 8. So that one does simplify down to 3/8, and so that is the same as 3/8. The second one, 9 and 24, well, 9 and 24 are both in the 3 times table. So I can divide both of these by 3. 9 divided by 3 is 3. 24 divided by 3 would be 8. So again, that one does simplify down to 3/8. This one over here though, 12 and 32, well, both numbers are even, so I can half them. Half of 12 would be 6. Half of 32 would be 16. Both those numbers are still even, so once again we can half. Half of 6 is 3. Half of 16 is 8. So yet again, that one is the same as 3/8. So it's got to be this one. But just to make sure, let's do it anyway. If a number ends in a 5 or a 0, it means we can divide it by 5. So because both these numbers end in a 5, we can divide each of them by 5. So first of all, 15 divided by 5 gives us 3, but 35 divided by 5 gives us 7. This is the odd one out. This one, 3/7, isn't 3/8, and so we need to be circling 15 over 35, because this one is the odd one out. This one doesn't fit the pattern. That one isn't the same as 3/8. Question 4. Pardon me. Simplify 5a minus, in brackets, 2a plus 6. Now, we've got minus sign here and a plus. What I'm going to suggest you do is think of a bracket as having an invisible 1 in front of it. 5a minus 1 bracket 2a plus 6. If there's no value in front of something in algebra, we can always assume there's an invisible 1. So after the minus, let's assume there's a minus 1. Then what we can do is expand out these brackets. So 5a is obviously just 5a. But now, looking at these brackets, we can expand these out by multiplying out the terms. So first of all, minus 1 multiplied by 2a. 1 times 2a would be 2a. So minus 1 multiplied by 2a would be minus 2a. And finally, minus 1 multiplied by 6. Well, 1 times 6 is obviously 6, but a minus value multiplied by a positive value makes the answer end up a minus overall. Mixed makes minus when we multiply. So now we can group together the a terms. 5a take away 2a means we'd be left with 3a. Finally, with minus 6 at the end. So our final answer is 3a minus 6. Common mistake there would be to say it's 3a plus 6, but we're actually taking away everything that's in the bracket. So what we need to circle here is the last option, which is 3a minus 6. Question 5. Complete the table for minutes and hours. So we're given that 30 minutes is half an hour, which is nice, but hopefully we already knew that, but 30 minutes is half an hour. So we need to do the same now for 40 minutes. What I'd suggest doing is thinking about how many minutes makes an hour first of all, and 60 minutes in an hour. So 40 minutes as a fraction of 1 hour would be 40 out of 60. Now, if we can, let's simplify this down slightly. If both numbers in a fraction are whole and end in a 0, we can effectively divide by 10, which looks the same as though the zeros are being knocked off. So that gives us 4 over 6, and that will simplify down yet again, because we can half 4 and we can half 6. Half of 4 is 2, half of 6 is 3. So 40 minutes is 2/3 of an hour. This one, 2 1/4 hours. Well, 2 hours, there's 60 minutes in 1 hour, so 2 hours is 60 times 2, which is 120 minutes. And also a quarter of an hour. A quarter of an hour is 15 minutes. To quarter something means to split it into 4. If you were to divide 60 into 4 bits, each bit would be 15 minutes. If you're going to be a quarter of an hour late, that's the same as saying you're going to be 15 minutes late. So 2 1/4 hours means 2 hours plus a quarter. So if we were to add these together, 120 plus 15, 0 plus 5 is 5, 2 plus 1 gives us 3, and the 1 on its own, 135. And so 2 1/4 hours is the same as 135 minutes. Question 6. We've got some numbers. 6 numbers, to be honest. And what we need to do now is write the numbers in pairs so that the sum of the numbers in each pair is the same. So like I said, if you count the numbers up, 1, 2, 3, 4, 5, 6. We've got 6 numbers. So that tells us, therefore, if we have 6 numbers, we're going to have 3 pairs of numbers. Now this question can be, on first sight, quite intimidating, but if you just take a step back and think about it calmly, each sum is going to be the same. So there's 3 pairs of numbers, and they all need to be adding up to the same thing. So what you could do is find out what the grand total of all these numbers here is. So let's just do that and add them up and take it from there. So first of all, we've got 9.6. If you're adding up decimals, by the way, make sure your decimal's in line all the way down. Apart from that, it's just like adding up normal numbers. 12.6, 15.4, 7.6, 12.4, and finally 17.4. So start with the left-hand side and let's add all these numbers up. So 6 plus 6 is 12, plus 4 is 16, plus 6 is 22, plus 4 is 26, plus this final 4 is 30. So put down the 0, make the decimal line up, and carry on an extra 3. It doesn't matter where you put the 3 to carry, just make sure you don't forget to add it on. Now we've got 3 plus 9 is 12, plus 2 is 14, plus 5 is 19, 19 plus 7 is 26, 26 plus 2 is 28, 28 plus 7 gives us 35. So put down the 5 and carry 3 again. Now what we need to do is the final column. 3 plus 1 is 4, 5, 6, 7. So our total is 75.0, which is just 75. So the total of all numbers is 75, and these are going to be split into 3 pairs of numbers. So if 75 is a total of all 3 pairs, each pair of numbers will be 75 divided by 3. So we can use a bus stop method for this one. 3 into 7 goes twice, with 1 left over, and 3 into 15 goes 5. And so each pair needs to add up to 25. Once you know that, we can just work out the rest quite easily. So 7.6 would have to go with 17.4, because those two added up would come to 25. So I've got those two sorted. Next one, 9.6. You can do these in any order, by the way. I'm just doing them starting with the smallest numbers here. 9.6 would go with 15.4. So I'll cross those out. And that just leaves 12.6 and 12.4. That's just one way of doing it. I'm going to show you now a slightly craftier way. So if I just put these numbers back as they were, for 6 numbers we could use a sort of symmetry argument for this one. What we could do is put these numbers in order of size, smallest first. So what we'd have first would be 7.6, after 7.6, 9.6, then 12.4, 12.6, 15.4, and at the end, 17.4. Now what you could do is actually just pair these up from end to end. And so 7.6 pairs up with 17.4. 9.6 pairs up with 15.4. And the last one, 12.4, pairs up with 12.6. So if you can spot that way of doing it, you might feel quite proud of yourself. I only thought of that way afterwards. But pairing them up from end to end, after ordering them from smallest to largest, is also quite a neat way of doing that one. So although it's 2 marks and can seem quite intimidating, don't panic, just think carefully what we can do and be systematic about it. Number 7. We have a triangle which has been drawn accurately apparently, and it says what type of triangle is it? Tick 2 boxes. So an acute angled triangle is where all angles are acute. So acute means less than 90 degrees. So because it says it's been drawn accurately, we could take advantage of this and just see if we're not sure. So if we get a protractor up, we could actually measure if we wanted each angle. So this first one, the first angle, is somewhere between 60 and 70. So that to me looks about 68 or so. 68. That's definitely less than 90. The other one on the other side, measure this angle, that's between 60 and 70 as well. That's again 68. So we can say this one's 68 too. And the one at the top, we can swivel it around slightly. Can put the protractor onto that one. Start from 0 and count up 10, 20, 30, 40. That looks to me to be about 44. So what we can do is take this away and say that's about 44, roughly. So all these angles, surprise, surprise, all these add up to 180, as you'd expect, but all these angles are acute, which you may have been able to just see by looking at it. So we can tick this one here. Because it's all like acute, definitely not obtuse angles, so we don't tick that. Equilateral, not necessarily, although the dashed lines do mean that these two sides are equal. These two sides are equal, and the two base angles are equal. If two sides and two angles are equal, we can say the triangle's isosceles. So these are the 2 boxes we need to tick, but it's acute angled and it's also isosceles. Question 8. Work out 51% of 400. Well, before anything happens to any number, we always start off with 100% of a number. So 100% of 400 is exactly 400. Now if we can work out what 1% is, we can work out whatever we want. And so if 100% is 400, how can we work out 1%? How do we go from 100 down to just 1? Well, if we take any number and divide it by itself, we'll always get 1. And so if we divide 100 by 100, that tells us what 1% is. But if we divide this side by 100, we'll need to do the same on the other side as well, to keep both sides equal and balanced. And so 400 divided by 100, how many hundreds in 400? That's exactly 4. Now we've got 1%, that's our ultimate building block. From 1% we can work out whatever we want. So to go from 1% up to 51%, we can just multiply 1% by 51, because we want to find out 51. And in the same way as before, if we multiply this side by 51, we'll have to do the same to this side as well. So if we can do 4 times 51, we've got the answer. So 51 times by 4. You could multiply any way you want to, as long as you get the correct answer. It really doesn't matter. 4 times 1 is 4. And then finally 4 times 5 is 20. And so 51 times by 4 is 204. Therefore, 51% of 400 gives us our answer of 204. Question 9. Write 180 grams as a fraction of 3 kilograms. Before we do anything though, just notice the difference in units. One, we're talking about grams. The other, we're talking about kilograms. So this is potentially a trap. We need to make sure the units are consistent. So we need to remember how many grams make a kilogram. And the answer to that is there's 1,000 grams in every kilogram. So if 1 kilogram is 1,000 grams, then 3 kilograms, like we've got here, is 3,000 grams. So now we can write this as a fraction with the units being consistent. Now whatever comes after the word of tells us what goes on the bottom of a fraction. Before the word of tells us what goes on top. So 180 goes on the top. Of after the of is 3 kilograms, which we've established is 3,000 grams. So that's our starting point. That's 1 mark. We get the final mark by giving the answer in its simplest form. Now both numbers are whole and end in a 0, and so what we can do is we can divide both top and bottom by 10. If we divide the top and bottom by 10, it looks like we're just knocking a 0 off each number. That would give us 18 on top, 300 at the bottom. Now both numbers are still even. Now if a number's even, it means you can half it. So if we divide 18 by 2, we can do the same to 300. Half of 18 is 9, and half of 300 is 150. Now forget that 0 for a second, just think of 15 and 9. 15 and 9, well they're both in the 3 times table, so we can divide top and bottom by 3. 9 divided by 3 would be 3. 15 divided by 3 is 5. Pop on the 0. That gives us 0. So, in its simplest form, our answer to this one, 180 grams as a fraction of 3 kilograms, is 3 out of 50. And that's our final answer. Question 10. Here are some properties of numbers. So, even, odd, prime, square, or 2 digits. And question A, part A rather, it says which 2 properties does a number 4 have? And so the number 4 is even. So we can circle A. Because it's even, it's not odd. A number can't be odd and even, it's one or the other. It's not prime. And 4 is definitely not 2 digits. 10, 11, 12 are 2 digits, but 4 is definitely single digits. It is, by process of elimination, therefore also got to be this one we tick. Process of elimination or not though, we should know that 4 is a square number, because 4 equals 2 times 2, which is 2 squared. And so it is a square number because it's 2 squared. It's a second square number. And so we circle A for even and D for square. That's the two we need to circle. Part B of question 10. Like I mentioned before about even and odd, a number is either even or odd, it can't be both. And so when the question asks, can one number have all of the properties? You need to tick no, it can't. The most obvious reason is that a number can't be both odd and even. A number can't be both odd and even at the same time. It's one or the other. So there might be other explanations you could have picked, but I think that's the most obvious explanation to pick you up the mark. And part C is one of these questions where there's absolutely loads of different possible answers you could come up with. As long as your answer's correct, you could put down more or less whatever you'd like. So for example, we could go for the number 16. 16, it's even, it's 2 digits, it's also a square number, it's 4 squared, 4 times 4 is 16, and so it's a square number because it's 4 squared. So this one, 16, we could say 16 ticks the box because it's A, even, it's D, a square number, and also E, it's 2 digits. And so that's one of many we could have picked. Just to give you another possible answer, we could have gone for the number 25 as well. Now 25 is a square number, so again 25 would be D for square. 25 is also an odd number, and 25 is 2 digits. So we could have said 25 or 16 or lots of other possible answers as well. Question 11. This is quite a challenging question. There's a few ways of tackling it. One way would just be to use trial and improvement. So by brute force, we could just try different coins, different value coins here. So that could be maybe £2, and maybe that could be £1. We just don't know, but we could do it by using trial and improvement. Just starting from basics. Let's read the question first of all, that's always a good start. Ranjit has 6 coins in his pocket. If he picks 5 of the coins, the most he could pick is £4.60. The least he could pick is £2.70. How much money does he have altogether? I've circled the coins here. Coin 1, 2, 3, 4, 5 and 6. I want you to imagine now as well that these are the coins listed in order of expensiveness. So the more valuable coins down this end, the less value coins down at the left hand side. So this is a arrow pointing to the more valuable ones. This is just showing you how you could do it quite systematically. So the most he could pick would happen if he picks the 5 most valuable coins. And so the 5 most valuable would be 1, 2, 3, 4, 5. The 5 at the right hand side. Now it says the least he could pick is £2.70, which should be the coins at the left hand side. This one, this one, this one, and that one. So if you think about it, whether he picks the most valuable coins or the least, he'll always pick the middle 4 coins. So he always picks the middle value 4 coins, no matter what. So the only difference he picks between the most valuable and the least valuable is the fact that the only difference comes from the end coins. So the difference is the end coins. Difference comes from the end coins. So what we can think of now is, what is the difference in amount of what he picks? The most he could pick is £4.60. The least he could pick would be £2.70. So if we find the difference between these two values, 0 takes 0 is 0. 6 takes 7 we can't do. So we borrow 1 from the 4, which becomes 3. The 1 we've borrowed goes next to the 6 to make it 16. 16 take away 7 is 9. Make sure the decimals line up. 3 take away 2 is 1. £1.90. So that now tells us difference in the end coins the one at the left, the one on the right, is £1.90. Now there's only one way that could happen, where the difference between two coins is £1.90, and that must be that one coin is £2 and the other coin must be 10p. Now you know that the cheapest is 10p and the most valuable coin is £2. That makes it much easier to work out what the other coins must be. So, for example, the middle 4 coins now need to add up to £2.60. So as long as we can do that, we're fine. So that isn't actually needed for the question though, however. Just going back to what I've said, the middle 2 coins would have to be £2.60, because £2.60 plus 10p gives us £2.70, and £2.60 plus £2 gives us £4.60. So, you know, we could make up whatever as long as it fits. So, the middle 4 coins, we could have another £2, then it could be 3 20p's. That would work, as one example. So how much money does he have altogether? Well, it would be the most expensive coins, which is £4.60, these 5 at the end, plus the 10p. So the total amount of money would be £4.70. And that's all we need to do. Getting there is the hard thing, but once you can work out that the cheapest must be 10p, the most valuable coin must be £2, it actually becomes much easier. Apart from that way of doing it, all I could suggest would be just trial and error. Try different combinations of coins and improve each time. If it's not right, try again. 4 marks, you could spend a good 5 or 6 minutes just using trial and error without stressing yourself out, because 4 marks, you could allow yourself 5 minutes to do that question without worrying too much. Question 12. We have 3 expressions. We've got, first of all, b over a take away b, and a, b. When a equals 2 and b equals minus 6, which expression has the smallest value? You must show your working. Well, first of all, let's just take it one step at a time. Let's do b over a first. So we're told that a is going to be 2 and b is going to be minus 6. And so, just looking at b over a for a second. So, b over a means b divided by a. So b is minus 6, a is 2. And so just to make this absolutely clear, it's going to colour code in b and a. So a, as I say, is 2, and b is minus 6. So in this case, minus 6 over 2 means minus 6 divided by 2. Well, 6 divided by 2 would be 3, but because that's a minus 6, that makes the final answer minus 3. So the next one we're going to have a look at is A take away B. A take away B just means whatever A is, which is 2, take away B. B in this case is minus 6. And so if we're going to do A take away B, that means 2 minus minus 6. If two minus signs are next to each other with nothing separating them at all, two minuses next to each other makes a positive. If we subtract a negative number, it's the same as addition. Two minuses work as a plus. 2 minus minus 6 is the same as 2 plus 6, which becomes 8. The final one we need to have a look at is AB. Now, if we've got two things in algebra just next to each other with no mathematical instruction telling us what to do with one and the other, it will always mean multiply. So AB means A multiplied by B, which is minus 6. And so A is 2 as usual, B is minus 6. Now 2 times minus 6, just think of it as 2 times 6 for now. 2 times 6 would be 12. But if one value is positive, the other is negative, the final value will be minus 12. So comparing these three different expressions, one is minus 3, the other is 8, the other is minus 12. The smallest value one is whichever is least. 8 clearly the biggest, followed by minus 3, but the smallest, the most negative, is minus 12, which is what we got by taking A multiplied by B. And so the expression which has the smallest value is AB. If you have a look at the question, it asks for the expression which has the smallest value. It doesn't actually ask for the value itself, just the expression which gives you the smallest value. The expression is this one here. So the actual answer is AB. Question 13. The table shows the ratio of teachers to children needed for two different activities. So we've got climbing and walking. There are 7 teachers to take children climbing. What is the greatest number of children that can go climbing? Well, the ratio says that for every 1 teacher we have, they can take 4 children. So for every 1 teacher, we can have up to 4 children. So the direct way will be to notice that for 7 teachers, that's 1 times 7. So 7 teachers can take 7 times as many children as 1 teacher can. And so 4 times 7 will be 28. So I've just multiplied each number in this ratio by 7. In the same way with equivalent fractions, what we do to one number, we do to the other. So times in both by 7, that means that 7 teachers could look after, at most, 28 children that are going climbing. Now, ratio can often be a source of confusion, so just to try and illustrate it, I've just done here a slightly silly diagram, but hopefully it does the trick. So what I've got is 1 teacher, 4 kids. Another 1 teacher, another 4 children. So if we imagine here, 7 teachers, 1, 2, 3, 4, and scrolling down, 5, 6, 7. So we've got 1, 2, 3, 4, 5, 6, 7 teachers, each one with 4 children. That's 4 lots of 7. Sorry, it's 7 lots of 4, I should say. 4, 8, 12, 16, 20, 24, 28. So we could look after 28 children altogether. Part B is similar. Part B says 49 children want to go walking. What's the smallest number of teachers needed? Well, 1 teacher is needed for every 9 children that go walking. And so would 1 teacher be enough? Obviously it wouldn't, because 1 teacher would only be able to look after 9 children. So we need more than 1 teacher. 2 teachers would be able to look after 18. But 18 is not enough. We want 49. So it's a case of building up in 9s until we have enough teachers. So 3 teachers could look after 3 lots of 9 children. 3 lots of 9 would be 27 children. Still not enough. A 4th teacher comes along. That teacher can look after another 9 children. Still not enough. 9 plus 9 plus 9 plus 9 is 36. Add in another teacher. That's another 9 children, which comes to 45. So there's almost enough with 5 teachers, but not quite, because 45 children isn't quite 49. So we'd need an extra 6th teacher that can look after as many as 9 other children. So 6 teachers can look after 54 children. Obviously we don't need to look after quite 54, but ultimately 5 teachers wouldn't be quite enough, so we'd need an extra 1 teacher. So the number of teachers needed would be 6. Question 14. Which one of these statements is true? Tick a box. So we're talking about a rectangle, R. A smaller rectangle's cut from R to form shape L. So we cut around R and make L. Which one of the statements is true? And we're asked to tick a box. So what you can imagine, because we're talking about perimeter for these ones. Perimeter just means the outside lengths. Now, because this has been cut, R's been cut and L's been formed, we can just imagine that these 2 bits have been cut away. So I'm just going to rearrange the outside bits of a shape and just put them together in a slightly different order. That makes shape L. So we've made shape L, but we still use the same outside length of a rectangle. That's a rectangle. If I move it back, move it back again, using the same outside lengths, no more or no less, I can make the shape L. And so actually the perimeter, the outside bit, is no different. Because the outside bit's no different, the perimeter is exactly the same as what it was before. So the perimeter of R is the same as the perimeter of L. So we need to tick the box which says the perimeters are the same. Question 15. Textbooks are stored on 2 shelves. Each shelf is 0.72 meters long and each textbook is 30 millimeters wide. And so what we're going to probably notice here is there's a difference in units, meters and millimeters. And so this question is begging us to do a conversion really. And so 1 meter is how many millimeters? We need to know that 1 meter is 1,000 millimeters. So to change from meters to millimeters, the conversion factor here, because one of the numbers is 1, the conversion factor will be the other number. So to change from meters to millimeters, we're going to have to multiply or divide by the number that isn't 1, in this case 1,000. So to change from meters to millimeters, we're going from a small number, 1, to a big number, 1,000. So we need to multiply it by 1,000. If we were going the other way around and changing from millimeters to meters, we'd be going from a big number to a small number. We'd be going the opposite way, so we'd do the opposite thing. Instead of timesing by 1,000, it'd be dividing by 1,000. But in this case, it's probably easiest if we change 0.72 meters into millimetres. And so 0.72 metres, if we multiply this by 1,000, it'll tell us how many millimetres that is. So if we're multiplying with decimals, it's easiest, I think, to just forget about the decimals for a second and treat them as whole numbers. We can put the decimal point back in afterwards. So imagine 0.72 as 72, then multiply that by 1,000. What we'd have is 3 zeros to add on. So 72 times 1 is 72, then add on the 3 zeros at the end, and we'd have 72,000. However, we do have the decimal point to put back in. Now in the actual question it was 0.72, which has 2 decimal places, 2 numbers after the decimal. If there's 2 numbers after the decimals in the question, there'll be 2 digits after the decimal in the answer. And so the decimal would have to actually go here. 720.00, we can just say that's 720 millimetres. So each textbook is 30 millimetres wide. And so how many textbooks can fit onto each shelf? We've just worked out that each shelf is 720 millimetres wide. And so what we're wanting to find out is how many 30s fit into 720. So what we need to do really now is 720 divided by 30. Now I can make these numbers slightly easier by treating it as a fraction and simplifying down slightly before we divide. Both 720 and 30 are whole numbers ending in a 0, so we can divide each by 10, which looks like we're just knocking a 0 off. That then gives us 72 divided by 3. So we can use the bus stop method to do this now. How many 3's fit into 7? We can fit 2 3's inside 7, but 2 3's are 6, so we've got 1 remainder. So that 2 is now 12 because of a remainder of 1 next to it. 3's into 12 goes 4 exactly, with no remainder, so we can stop. That's our final answer. And so 72 divided by 3 equals 24. So that tells us that we can get 24 books on each shelf. So 24 on the top and 24 on the bottom. So the total number of books we can fit in this bookcase altogether is 24 on the top plus an extra 24 on the bottom, which comes to a total of 48 books. So the question where it says, can 50 textbooks be stored on these shelves? Just remember to always answer the question it's asked you. Can 50 textbooks be stored? Well, we've just calculated that the total number that can be stored is 48. Therefore, for this question, our answer is no. We can't store 50. The maximum we can store is 48. So there's going to be 2 books without any home. Question 16. All tickets for the concert are the same price. Amy and Dan pay £63 altogether for some tickets. Amy pays £24.50 for 7 tickets. The question asks, how many tickets does Dan buy? So what we could do first of all is try to work out how much each ticket is. So if Amy pays £24.50 for 7 tickets, then the price of 1 ticket will be £24.50 divided by 7. So 24.50 divided by 7. And for this, we could use the old trusted bus stop method. So put £24.50 on the inside and make sure the decimal lines up on the top and the bottom. So first of all, can we fit 7 into 2? No, we can't. So that 2 is a remainder, which moves on next to the 4. So now we've got 7s into 24, which we can fit 3. 3 7s are 21, so we have 3 left over. 7s into 35 goes 5 exactly, with nothing left over, and 7s into 0 goes 0 times. And so that tells us that each ticket is £3.50. So each ticket is £3.50. So Amy pays £24.50 for hers. They pay £63 altogether, and so Dan must pay the rest of the £63. We can work out how much Dan pays by doing £63 take away the £24.50 that Amy pays. So 0 take away 0 is 0. 0 take away 5 we can't do, so we need to borrow 1 from this 3, which then becomes 2. The one we've borrowed can now move over, so that 0 now becomes 10. Again, just make sure the decimals line up at the top and the bottom. 10 take away 5 is 5. 2 take away 4 we can't do, so again we can borrow 1 from the next number, which is a 6. Borrow 1 from the 6, that becomes a 5. And the one we've borrowed goes next to this 2, which now becomes 12. 12 take away 4 is 8. And finally 5 take away 2 is 3. And so that tells us that Dan spends £38.50. Just going back to the price of each ticket is £3.50. So what we can do is see how many £3.50s we'd need to make £38.50. So if we just get this over here for a second, just get some more space. If one ticket is £3.50, then 10 tickets will be 10 times as much. So if we multiply this by 10, we get £35. Plus an extra 1 ticket to get it to 11. And 11 tickets would be £38.50. Which is actually what we said Dan spends. So Dan spends £38.50, which is the same as 11 tickets. Therefore, when it says how many tickets does Dan buy, he must have bought 11 tickets. So the final answer for this is that he buys 11 tickets. Question 17. We have a graph of y equals 5 take away x for values of x from 0 to 5. It then asks us on the same grid to draw the graph of y equals x plus 1. So what we could do for this would be a table of values for x and y. And it says x is ranging from 0 to 5. And so we can just do this step by step if we'd want. X is 4, finally x is 5. And so what it says here is that y is x plus 1. So whatever x is, we just add 1 to it, and that tells us what y will be. So each of these values of x, we're just going to add 1 to them. 0 plus 1 is 1, 1 plus 1 is 2, 2 plus 1 is 3, and so on. And so these are our coordinates. So x is 0, y is 1. X is 1, y is 2. So what's going to happen is, again, it's going to be a straight line. Going up, and we'll cross the line which has been already drawn on. So then we can just do a straight line going through these points. So that's the graph drawn. Part B then says use the graphs to solve the simultaneous equations y equals 5 minus x. Well, y equals 5 minus x is the one which has already been pre-drawn. We were given this one already, which was the first one, which is here. So y equals 5 minus x and y equals x plus 1. The equations are solved when both these are the same value, and them both being the same value is represented on the graph by where the graphs cross. So they cross over at this point. So at that point, that's when y is both 5 minus x and x plus 1. And so where two graphs cross represents the solution of simultaneous equations. So in this case, the solution is x at this point where they cross over is 2, and y is 3. And that's the answer to the simultaneous equations. Number 18, we're talking about sales of food and drink at a market stall. So we need to have a look at this question and spot what mistakes have been made. So the first thing I'd say might be the most obvious to notice is it's a stacked bar chart. It's a dual bar chart with two different types of bar, but there's no key telling us what the two different bars represent. And so I'd say the first thing to write down is that there's no key. To tell us about the bars. There's no key telling us what the two bars represent. Telling us what the bars represent. Sorry about my horrible handwriting. So first of all, I'd say there's no key telling us what the bars represent. Then if you have a look on Friday, I can only presume that from Thursday, food is 34, and so that must be food, and drink must be the other 16. 34 plus 16 takes you to 50, so you can work out yourself that what they must mean is that the lined bar means food, the solid bar means drink. So based on that, looking at Friday, the sales of drink only is £48. But this is the total height of all two bars. So on Friday, the total height is £48, whereas that can't be true because it's 48 for the drink only. Then you need an extra 22 for the sales of food. So the total height for the Friday bar should be 48 plus 22. It should be up at 70. So in terms of writing that down in words, maybe something along these lines. So for Friday, the sales of drink only is £48. But she's drawn £48 as the total of both food and drink. Which is clearly going to be wrong, because the total of both food and drink should be 70. Mistake 3, as we've established, the lined bars must be food and the other one, the grey one, is drink. So on Thursday and Friday, that would make sense. But if you look on Saturday, it seems like she's switched them around because for Saturday the sales of food are 46, the sales of drink is 28, but the bar which is 28 high for Saturday for the drink is the lined bar. So that's now representing drink, and that's now representing food. So it's like she's switched what the bars represent. So on Saturday, the lined bars and the grey bar have switched. What they represent. It's quite a hard one to word, really, this one. For that reason, I'd say question 18 is quite a tough one to explain the three mistakes. It's not the easiest question in terms of explaining what mistakes have been made with a bar chart, but those are the three mistakes I would suggest which have been made, plus guidelines for how you might want to word each mistake. Question 19. Sam wants to buy a camera for £345. He's already saved £96. So each week he gets paid £80 and he saves 30% of his pay. How many more weeks must he save? Well, first of all, from these first two lines here, it's going to cost him £345, but he's saved £96. So he still has to save some more. So the amount still to save we can work out. So he needs to save £345 in total, of which he's already saved 96. So 345 take away 96 will tell us how much he still needs to save. 5 take away 6 we can't do, so we can borrow one from the 4, which becomes a 3, and the one we've borrowed goes next to the 5, which now becomes 15. So 15 take away 6 is 9. 3 take away 9 we can't do, so we'd have to borrow one from the 3, which now becomes a 2. And the one we've borrowed goes next to this 3, which now becomes 13. Now 13 take away 9 we can do, which is 4. And 2 take away nothing beneath it is 2. And so the amount of money still to be saved is 249. Still got to save £249. Now it tells us here how much he's going to save each week. He saves 30% of his pay each week. 100% of any number is the number itself. So 100% of 80 will be 80. Now from this we can easily enough work out 10% by dividing by 10. To go from 100 to 10 we can divide by 10. So we need to do the same to the 80. 80 divided by 10 is 8. Because 180 are whole numbers, it just looks like we're knocking a 0 off each one. So 10% is 8, but we're told here that he actually saves 30% each week. So to go from 10% to 30%, 30% is 3 lots of 10. So we can multiply by 3 to work out what 30% is. So over here, 8 multiplied by 3 would give us 24. So £24 is what he saves a week. So how many more weeks must he save? So it's basically how many 24s are needed to get to at least 249. Well, in 1 week's time, he'd save an extra £24. which is nowhere near because his target is 249. So in 10 weeks, he'd be able to save 10 times 24, which would be 240, which is nearly there. He's still £9 short though. So although 10 weeks is nearly enough, it's not quite enough. So you'd need an extra week, which would be 11 weeks in total. In 11 weeks, he'd be able to save 240 plus an extra £24, which should be 264, which should be more than enough. So although 10 weeks is nearly enough, it's not quite enough. You need an extra week. So the total number of weeks that he must save, in addition to what he saved already, would be 11 more weeks. Question 20. W and X are whole numbers. We're told that W has to be bigger than 40. X must be less than 30. Remember, the crocodile's open mouth faces the bigger thing. And so because the crocodile is rather eating W than 40, W is bigger than 40, X is less than 30. Work out the smallest value of W minus X. And the smallest value of W minus X will be when W is its smallest, and we're taking away the biggest possible number from it. So into it when X is the biggest. So W has got to be bigger than 40, so it's not allowed to be 40. The next smallest number after 40 is 41. And X at its biggest, well, X has got to be less than 30. It can't be equal to 30. So the biggest number it could possibly be without touching 30 would be 29. And so the smallest value of W minus X would be 41 take away 29, which should be a total of 12. So the smallest value of W minus X is 12. Now for part B, we've now got Y and Z. We need to work out the largest possible value of Y plus Z. And so here, we're told Y needs to be less than 60. So Y can be all the way up to 60 without being 60 itself. So it could be 55, could be 56, 57, could be 58, could be 59. But it couldn't be 60. Whereas Z, if you have a look at Z, it's actually got this inequality symbol here. So Z could be equal to 50 because underneath the inequality symbol is another line which represents that Z could be smaller than 50 or equal to 50. And so Z could be 48, could be 49, could be 50. So the largest value of Y plus Z is when both of these are at their largest. So the largest value of Y is 59. The largest value of Z will be 50. So the largest value of Y plus Z will be 59 plus 50, which will be 109. Question 21. Work out 2.4 times 0.002. So this one, decimal multiplication. So what I'd suggest is the easiest thing when multiplying decimals is to pretend the number isn't a decimal at all. So take the decimals out, it'd become 24 times 2, which is 48. So the answer is going to look something like 48. Now we can put the decimal places back in. In the question, there's a total of 4 decimal places. 2.4 has 1 decimal place, and 0.002 has 3 decimal places. So in total, 1 plus 3, there's going to be 4 decimal places in the answer. the number of decimal places in the answer is always the same as the number of decimal places in the question when we're multiplying decimals. And so we know that the answer is going to involve 48, but what we need here is 4 digits after the decimal place. So this one's going to be 0.0048. I can put this answer in like this. Part B, write 1.2 times 10 to the power minus 5 as an ordinary number. So this is a number written in standard form. And standard form, the most important thing, is the power of 10. The power of 10 essentially tells us how the decimal is going to move. Because the power of 10 is minus, it means the decimal is going to move to the left 5 digits. So if the decimal was between the 1 and the 2, it's now going to go over the 1, over another number, 3, 4, 5, and we'll land here. So first of all, the decimal jumps over the 1. Here it's jumping over nothing. Nothing in maths is a 0. So fill in the blanks with zeros and put a 0 before the decimal as well. And so what we'll end up with is 0.000012. Now, if we have a number in standard form and the power of 10 is minus, there's a quick tip to note. If it's a minus power of 10, the number after the minus will always tell you how many zeros comes before the first non-zero digits. So here, because the power is minus 5, we've got 5 zeros before the first non-zero digits, which in this case is the 1 and the 2. 1, 2, 3, 4, 5. Minus 5, so 5 zeros come first. Part C, we need to write this number, 2,500,000, in standard form. So I'm just going to write out the number here. If a number is a whole number without no decimal showing, the decimal will always be an invisible one at the end of a number. Now to put this into standard form, the first part of a number needs to be between 1 and 10. So where would I put a decimal in this number to make it somewhere between 1 and 10? The decimal would have to go in between the 2 and the 5. If I put the decimal in between the 2 and the 5, the number would just become 2.5 and the other zeros wouldn't be needed. And so it's going to be 2.5 multiplied by 10 to a certain power. Now the power of 10 is found by looking at how many digits are between where the decimal actually is and where the decimal needs to be, which is here. Between these two places, there's a total of 6 digits. And so the power of 10 is going to be positive 6, not minus 6. Positive powers if we're talking about big numbers, negative powers if you're talking about small numbers. 2,500,000 I'd say would be quite big, so that's a positive 6. Question 22. We have got a diagram about scores of class 3A in a spelling test. So part A, a student's chosen at random from the class, work out the probability that the student's score was the mode for the class. And so what we need to do first of all is just think about what the mode means. Mode will always mean the most common. In this case, because we're talking about score, it's the most common score. So it's the score of the highest frequency. So let's have a look. So the mode, which one has the highest frequency, which bar is the biggest? It's going to be 8. Most common score is 8. Now, what we need to do as well to work out the probability that the student chosen at random scored the mode is work out the total number of students altogether. So some students scored 3, some students scored a 4, 2 students scored 4. So for total number of students, we can calculate here. So 2 students scored 4. That's 3 students that scored a 5. 6 students scored a 6. 7 students scored 7. And finally, 9 students scored 8. So 2 plus 3 is 5, plus 6 is 11. 11 plus 7 is 18. 18 plus 9 is 27. And so, of those 27 students, how many scored the mode? Well, how many scored the mode, which was 8? We can have a look at this by just doing a line across. And as I said before, there were 9 students that scored the mode. And so because there's 27 students in total, we can say that 9 out of the 27 students scored the modal score of 8. So for our answer, we can just put 9 over 27. If it's a probability, we don't actually need to simplify. But if you wanted to simplify, we could say that 9 over 27 is the same as 1/3, because 9 and 27 both divide by 9. Now part B shows us a chart for class 3B. So it's information about the scores of class 3B in the same spelling test. It says show that class 3A had more consistent scores than class 3B. Now consistent implies we need to work out the range. If ever you see a question asking about consistency, be thinking the range. The smaller the range, the better the consistency. So I'll write that down just so you can try to remember it. Smaller range means more consistent. So for class 3A, the range is the highest value, take away the lowest. So for class 3A, the highest score was 8, and the lowest score was a 4. And so the range for class A is 8 take away 4, which is 4. So again, just to remind you that the range is the highest score take away the lowest score, which is 4. So using the same idea now for class 3B, the range is going to be the highest. Now for class 3B, the highest score again was an 8, but the lowest score down here was only a 3. So for class 3B, the range is 8 take away 3, which is 5. So class 3B had a higher range. So because class 3A had the smaller range, it's more consistent. So just a sentence to that effect. Class 3A had more consistent scores because it had, or because it has, a smaller range of scores. The smaller the range, the more consistent we can say the data is. And finally, for question 22, part C, it says Lucy is one of the 29 students in class 3B. Her score was the same as the median for her class. Work out her score. Now, median means the middle value. Median means the middle value. So what we need to do here is imagine if there's 29 students put in order from worst score to best score, the middle student would actually be the 15th student. But for 2 marks, what I'd suggest, if you've got the time, we can list it out and do it exhaustively. So first of all, how many students scored 3 marks? There was 2. So 2 students scored 3. Next, how many students scored 4? Again, there was 2. How many students scored a 5? 4 students scored a 5. So write down 4 5s. 1, 2, 3, 4. How many students scored a 6? This one over here is between 6 and 8, so that's 7. So 7 students scored 6. So 1, 2, 3, 4, 5, 6, 7. How many students scored 7? 8 students scored 7. So 8 7s. 1, 2, 3, 4, 5, 6, 7, 8. And finally, how many students scored an 8? There were 6. So 6 8s. 1, 2, 3, 4, 5, and 6. Now what we can do is work in from end to end until we find out the middle score. And so the middle score won't be the end score, so it won't be the 3 or that 8, or that one, or that one. So it might take time, but it's worth it to make sure of the marks. So just work in from end to end. Cross one off at one end, cross one off at the other end, and just work in slowly but surely. So by now you can see it's either going to be a 6 or a 7. Getting closer, closer. And as you can see, there's only one number left. The number that's left is the number 6. Therefore, the median, the number in the middle, is 6. So if she scored the same as the median, she must have scored 6. Put it back in black. And that's our answer to 22 part C. Question 23. Kelly's trying to work out the 2 values of W for which 3W minus W cubed equals 2. Her values are 1 and minus 1. Are her values correct? You must show you're working. So for this question, I'd suggest doing a table and just being systematic. So write down what W is, what Kelly's picking. So she's saying it's 1 and minus 1. So if W is 1 or minus 1, then work out what 3W would be. then work out what w cubed would be. And finally, what would 3w minus w cubed be? And we can compare and see if it's 2. So all we're doing here is just seeing for each value of w, what's 3w and what's w cubed. So the easiest value by far is when w is 1. Positive numbers are just easier to deal with than negative numbers. So if w is 1, 3w would mean 3 times 1, which would be 3. And w cubed means 1 times 1 times 1, which would be 1. And then 3w take away w cubed would be 3 take away 1, which is 2. And so when w equals 1, it works, because 3w is 3, and w cubed is 1, 3 take away 1 is definitely 2, so that's fine. But when w is minus 1, so it gets a bit trickier. We've already said that 3 times 1 is 3, and so 3 times minus 1 would be minus 3. Now multiplying is even harder. So minus 1 cubed means minus 1 multiplied by minus 1 multiplied by minus 1 again. So if we just have a look at minus 1 times minus 1, if you're multiplying two minus numbers together, if the overall answer ends up being positive. So minus times a minus ends up being positive. So it's the same as 1 times 1, which is 1. But then we're multiplying that by minus 1 again. So as if that wasn't confusing enough, we've now got positive 1 multiplied by a third final minus 1. And so that 1's positive, I'm just going to put positive in brackets, and that 1 is minus. And so now the signs are mixed. We're multiplying two numbers together, and the signs are mixed. 1's plus, 1's minus. Mixed makes minus. So 1 multiplied by minus 1. The final answer for w cubed, when w is minus 1, is that w cubed is minus 1. So minus 1 times minus 1 times minus 1 equals minus 1. So in this case, 3w is minus 3 minus w cubed, which is minus 1. That's the same as minus 3. And these two minuses which are together and almost touching, two minuses together, it's the same as a plus. So minus 3, then go up in the positive direction by 1. That takes us to minus 2. And so are her values correct? Well, when w is 1, that's correct. But when w is minus 1, she's not correct. And so in summary, her values sort of yes and no. So she's correct when w is minus 1. Sorry, she's correct for w equals 1, I mean to say. But incorrect for when w equals minus 1. Question 24, we've got a semicircle. Now before we get on with semicircles, if you're getting hungry, I could just recommend having a pie right about now. In fact, pies are so nice, particularly chicken pies. I would even say chicken pies are delicious. Now if you're vegetarian, it's always important to have vegetarian options. That could be a cherry pie if you prefer. I think I'll go for chicken. Chicken pie is delicious, and for dessert, how about an apple pie? If chicken pie is delicious, apple pies are too. That's my silly way of remembering the formula for the circumference of a circle and the area of a circle. So for this question, because we're after the area of a semicircle, I'll come to a semicircle in a second, we're going to use this formula here. Area of a circle is pi times r squared. A semicircle means half of a circle. R means radius, which is 8. So for the full circle, the area is pi multiplied by the radius, which is 8, squared. Now according to BIDMAS, do we multiply or do the power first? We need to work out the power first. So pi times 8 squared is 64. So we've got pi times 64. Now in algebra you don't need a multiplication sign. We can just put 64 pi. I'm leaving pi in there. I know pi is actually equal to 3.142-ish, but because the question says give your answer in terms of pi, what that means is we leave the pi symbol in our calculations. If ever a question asks you to give an answer in terms of pi, it means leave the pi symbol in the calculations and the answer. So, as I was saying, if it were a full circle, the area would be pi times 8 squared, pi times 64, which would be 64 pi. But because it's a semicircle, semicircle means just half of a circle. So we take the full circle, and to make half of it, we're going to divide by 2. So because it's a semicircle, we're going to take the full circle and divide by 2. So 64 pi divided by 2, what's half of 64 pies? If you're not hungry enough to eat 64 pies, how many pies would you eat? Well, you'd only have 32 pies, which is barely anything really. 64 pi divided by 2 would be 32 pi. And so that's our answer, 32 pi square centimetres. Question 25. Work out 2 3/4 multiplied by 1 5/7. Give your answer as a mixed number in its simplest form. So this question here, if ever it asks us for an answer in simplest form, that's a clue that we're going to have to simplify it down at some stage. But first of all, if ever you've got mixed numbers, what we need to do is change them into top-heavy fractions. Dealing with mixed numbers is just harder. So to change to a top-heavy fraction, you take the whole number and multiply by the denominator. So the whole number multiplied by the bottom number, then we add on the top. And we do the same for the second one as well. Multiply the whole number by the bottom, then add on the top of the fraction. So this one over here, 2 times 4 is 8, plus 3 becomes 11. At this stage, just leave the bottom numbers as they are. That was a 4, leave it as a 4. And the top number now, for the second fraction, becomes 1 times 7, which is 7, plus on the top number, which is 5. 7 plus 5 is 12. So what we have now is 11 over 4 multiplied by 12 over 7. Now at this stage, what we can do is just multiply across top times top and bottom times bottom. So what we need to do over here, first of all, is 11 multiplied by 12, whichever way you want to do it. 11 times 12, well 10 times 12 is 120. Add on an extra 12, 120 plus 12, you should get is 132. And so the top number is 132. The bottom number becomes 4 times 7, which is 28. Now, what we can do, because both these numbers are even, we can half the top and the bottom. So we can divide the top by 2 and divide the bottom number by 2. You can simplify down now or later, but I'd suggest simplifying down first if you can, to make sure you don't forget, if nothing else. So half of 28 is 14. Half of 132. If you're not sure, we can always just use a bus stop method, because it'll always work. 2 into 1 doesn't fit, so the remainder is 1. So now we've got 2's into 13. 2 goes into 13 6 times, with 1 left over. Now finally 2's into 12 is 6. So half of 132 is 66. Both numbers are still even. 66 and 14 are still even. So again, we can simplify down further by dividing both top and bottom by 2. Half of 66 is 33. Half of 14 is 7. Now we can't divide them again. Now finally, put it back into a mixed number like it asks. We do this by seeing how many times we can fit 7 into 33. 7 into 33 will go 4 times. 4 7s are 28. Then how far away from 33 is 28? Well, 33 take away 28 would give us 5. So back as a mixed number, 33 over 7 becomes 4 with 5/7 left over. So back as a mixed number in its simplest form, we'd have this as our final answer. And so on our answer line, we put 4 and 5/7. Question 26. Solve 5x minus 2, inequality symbol, 3x plus 11. If we're solving inequalities, we may as well just treat the inequality symbol as an equals sign, because essentially it's just a distraction, to be honest. So treat it as an equals, but bear in mind at the end to replace the equals sign with the actual inequality symbol as it was. Now, if we've got x's or unknown letters on both sides of the equals or on an inequality symbol, what we need to do is have all the x's or unknown letters on one side and all the units on the other. And so what we need to do is to get all the x's onto one side. So what we could do is take away 3x from the right hand side, and to keep the balance, take away 3x's from this side as well, to make sure it still balances out. What it looks like is happening is it looks like that 3x swaps side, and as it swaps a side, it swaps a sign from being a plus 3x to a minus 3x. 5x take away 3x, we've got 2x's left. That's how it looks, but all we're actually doing is just knocking off 3x's from each side. So if we do that, 5x take away 3x's means we've got 2x's left. We've still got minus 2 as well. And on the right hand side of the equals, 3x take away 3x means we've got no x's left at all. All we'd have left on the right hand side would be 11. So now we've got 2x minus 2 equals 11. Now this can be solved in quite a few different ways really, but let's just stick with the whole balancing method. So we want to get rid of this minus 2. How do we get rid of minus 2? We can do the opposite, which is plus 2. But if we add 2 to this side, we need to do the same over here and add 2 to this side. Again, what it looks like is happening is a minus 2 swaps side and swaps sign to a plus. So the next step, after we've added 2 to both sides, we'd have 2x equals 13. But our goal isn't to know what 2x is worth, we want to have just 1x. To go from 2x to 1x, we can just half each side. That 2 is multiplying the x, so opposite of multiply, when the 2 swaps over, swap side, swap sign, opposite of multiply, it now becomes divide on the other side. So the answer would be x is 13 divided by 2, which is either 6.5 or 6.5. But as I said, it wasn't actually an equal sign, it was this inequality symbol. So just remember at the end to change back to the symbol you need. So it's actually x must be bigger than 6.5. Or you could write 6.5 if you really wanted to. It doesn't particularly matter. Question 27. We've got 2 different sequences. So the first sequence, it says that the nth term of a particular sequence is 2n plus 1. Now if a sequence is 2n plus 1, what it means is, because the number in front of the n is a 2, it means the sequence is going up in gaps of 2, but it's going to be 1 higher than the 2 times table. So the 2 times table starts with a number 2. 2 plus 1 is 3. So for the first sequence, the first number would be a 3. And it's going to be going up in 2s because the number in front of the n is a 2. So 3 plus 2 is 5, 7, 9, 11. Now just skimming through to the question, we want to work out the numbers that are in both sequences and between 20 and 40. So we're going to build up this sequence, keep adding on 2 to find out the values which are between 20 and 40. So it might take time, but it doesn't matter. It's worth just taking your time to get your marks rather than rushing and not getting them. So 9 plus 2 is 11, plus 2 is 13. Keep going. It's essentially the sequence of all odd numbers, this. 19 plus 2 is 21, 23, 25, 27, and we're running out of space. So keep going. After 27, be 29, then 31, 33, 35, 37, and 39. Beyond 39 we've got 41, but we're just interested in the numbers which are between 20 and 40. And so between 20 and 40, for this sequence, we've got all these numbers here to pick up. But of course, this question also mentions a second sequence, 3n minus 1. So what we're going to do now is do this sequence. Now 3n tells us that the sequence is going to be going up in gaps of 3s. Minus 1 tells us that the sequence is going to be 1 lower than the 3 times table. The sequence that goes up in 3s is the 3 times table, what you taught from school. The minus 1 means we start 1 lower. So 1 lower than 3 is 2. And what we're going to be doing is going up in gaps of 3, because the number in front of n tells us what the sequence is going up in. So going up in gaps of 3, 2 plus 3 is 5, 5 plus 3 is 8. 8 plus 3 is 11. And we keep going up, adding 3 on each time. 23, 26, 29, 32. 32 plus 3 is 35. 35 add 3, 38. And beyond that we'd have 41. So that's all the numbers we need to consider. So between 20 and 40 for this sequence, we've got these numbers here. So work out the three numbers that are in both sequences and between 20 and 40. So just scan your eyes. 20 and 21, they're not in each. 23 is 25? No. 26? No. 29? Aha! 29's in each. And the other one that's in each is 35. And so the three numbers that are in each sequence are 23, 29, and 35. Question 28 is pretty much a beast of a ratio question. We've got white paint, which costs £2.80 per litre, and also blue paint. It's mixed together in the ratio 3 lots of white to 2 lots of blue. So it's mixed together, so white plus blue gives us the total, which this question is calling the mixture. So using the numbers in the ratio which have been given to us, 3.2, that could mean 3 millilitres, 2 millilitres, or 3 tonnes and 2 tonnes. It doesn't matter as long as you're using the same units. But because the units we're being told we're working in litres, we may as well measure these as litres. So if we had 3 litres of white, that would be mixed with 2 litres of blue, which would make us a total of 5 litres of mixture. So what we're told is the white paint costs £2.80 per litre. And so if you had 3 litres of white, that would be £2.80 times 3. And so we can do this. Forget the decimal first of all, and just do 280 times 3. Well, 3 times 0 is 0. 3 times 8 is 24. So put the 4 down, carry an extra 2 along. And then 3 times 2 is 6. 6 plus 2 is 8. But of course it wasn't 280, it was £2.80, which has 2 decimals in it. 2 decimal places. So 2 decimal places in the question, we need 2 decimal places in the answer. And so 3 litres of white paint would cost us £8.40. And that would be mixed with 2 litres of blue paint. 1 litre costs £3.50. So 2 litres, £3.50 times 2 would be £7. So in total, £8.40 for the white, plus £7 for the blue, would come to a total of £15.40. Now, we can always add it up by doing it this way, just to be sure. £8.40 plus £7. 0 plus 0 is 0. 4 plus 0 is 4. 8 plus 7 is 15. Make sure the decimal lines up. And so 5 litres of a mixture would set us back £15.40. And that is maybe the easiest way in to this question. And so 5 litres costs £15.40. Only trouble now is we don't want to know the cost of 5 litres, we want to know the cost of 18 litres. What we could do first of all is work out the cost of 1 litre. Once we work out the cost of 1 litre, we can just multiply that by whatever we want. So to go from 5 down to just 1 litre, what would we divide 5 by to get 1? The answer is we divide it by itself, because any number divided by itself equals 1. But we need to do the same to this other side as well to keep it in balance. So 1 litre would be £15.40 divided by 5, which we can just do over here using the trusty bus stop method. So 5s into 1 won't fit, so we've got 1 left over, which is the remainder. 5s into 15 goes exactly 3 times. Just make sure the dots line up. 5 into 4 doesn't fit, so it goes 0 times, and that 4 is still left over as a remainder. Finally, 5s into 40 fits 8, and so that tells us that 1 litre of the mixture is £3 8p. So 18 litres we can work out by doing 1 litre and multiplying it by 18. This is the hardest part, perhaps. 1 times 18 gets us to 18. 18 times as much paint will cost 18 times the price. So now we need to do £3 8 times 18. So, just for the sake of variety, I'm going to do £3 8p times 18 using the Chinese method. So, for this method, what we can do is set out a grid. Whoops, a bit slanted that. There we go, that's a bit better. Set out a grid. Now, £3 8 is 3 digits, and 18 is 2 digits. So we're going to make a box 3 by 2. So here I'm going to put 3, 0, 8 for £3 and 8. We're multiplying that by 18, so put 18 over here. Now we need to split the boxes using this method from corner to corner, like this. You don't have to use any method at all. Doesn't need to be the Chinese method, doesn't need to be any method, as long as you've got a method which you're comfortable with, which works. But I quite like this way, so I'm going to use this way and demonstrate it. So £3 8 times 18. 8 times 1 would be 8. So you put 0 in this top box, 8 in the bottom box. 8 times 8 is 64. So 6 and 4 in the bottom box. 0 multiplied by anything is always going to be 0. So this middle column just filled with zeros is easy. Finally, 3 times 1 is 3. And this final box, 3 times 8 is 24. Now we add up the numbers going diagonally downwards. So the first number here is a 4, which we just write down. This next diagonal row, 8 plus 6 is 14, plus 0 is still just 14. So we put down 4 and carry 1 across. This one here, 0 plus 0 plus 0 is nothing, plus 4 is 4, plus this one I've carried makes it a 5. Finally, 0 plus 3 plus 2 is 5. And this final number is a 0, which we can just leave out because 0 is just nothing. But of course, it wasn't £308, it was £3 and 8p. which has 2 decimal places in it. 2 decimal places in the question means we also need 2 decimal places in the answer. And so the decimal point would go here. So that tells us the cost of 18 litres will be a grand total of £55 and 44 pence. So the final question, the cost of 18 litres of a mixture, after all that hard work, is £55 44 pence. That might well be the hardest question on the entire paper, in my opinion. We're on to the last 2 questions now. Question 29. I've got sketches of 4 triangles, not drawn accurately, so don't be measuring this with a ruler. Now this is trigonometry, which is quite a rarity in non-calculator papers, but needless to say, here it is. It says circle the value of cos 50 to 2 decimal places. But first of all, if you've got a question involving trigonometry, it's worth remembering the 3 magic triangles, which you should know, so katoa. Now cos stands for, well, sorry, C stands for cos. And so when it says cos 50, that's a clue that we're after the cosine. Now trigonometry, we can only apply that to right-angled triangles. So these triangles here, we can use it on, because it's got a right angle. The little square in the corner means it's a 90-degree right angle. These 2 aren't, so these 2 questions here are just there to throw you off course, so forget those for now. It's going to be one of these. Now because it's cos, it's the ka triangle. A stands for the adjacent side, H is the hypotenuse, which is the longest. So for each triangle, that's for H. The adjacent side is the side which has the angle in question and the right angle on it. The way I'd think about it is work out the opposite side and the hypotenuse first. The opposite side is a side opposite the angle we're talking about. And so in both triangles, the opposite side is one on the right hand side, and the adjacent is the bottom side of each triangle. And so which of these triangles do we know the adjacent and the hypotenuse? The answer is the bottom triangle. So what we need to do here is just circle this bottom triangle. And going back to this triangle here, cos of 50, cos of the angle, is the adjacent over the hypotenuse. Just using the definition of what cos means. Cos means adjacent divided by hypotenuse. So for this one, the adjacent side is 0.64. Okay. Adjacent side 0.64, and the hypotenuse, the longest side, is just 1. So 1 is the hypotenuse. I might as well colour that in green because I like just colouring in things. Never really grew up. Anyway, enough of my problems. A over H, 0.64 divided by 1. Any number divided by 1 just stays as it is. And so the cos of 50 would be 0.64. And so the one we need to circle is this one here, 0.64. Now for part B, it says work out the value of x, give your answer to 1 decimal place of this triangle. Now this triangle here has got the same angle and the same hypotenuse. Well, the hypotenuse is 4, I should say, but it's a 50-degree angle. So what we need to look at is which triangle this corresponds to. So 4, it's got a right angle and a 50-degree angle, so it's going to correspond to this triangle over here. Because we want to work out x, which is the bottom side. This triangle over here, importantly, is similar to this one. What side do we know on each? We know the hypotenuse on each. This hypotenuse is 1. The hypotenuse on here is 4. So importantly, this triangle is 4 times bigger than the yellow one I've highlighted. 1 times 4 is 4, and so this bottom side here will be 4 times bigger the bottom side on this smaller one. And so x will be 0.64 times by 4. So you might want to imagine that's 64 pence times 4. Whichever way you want to do it, doesn't matter as long as you're comfortable doing multiplication involving decimals. If you're not comfortable with decimals, forget there's a decimal there and treat it as 64 times 4. Well, 4 times 4 is 16. Put the 6, carry the 1. And 4 times 6 is 24, plus the 1 over here is 25. So that'd be 256. However, the question has 2 decimal places in it, so we need 2 decimal places in our answer. And so the decimal would go in after the 2, which would make 0.64 times 4 equal to 2.56. But if we read the question carefully, we need to give our answer to 1 decimal place. And so we're going to round it off at 2.5. It's either going to be 2.5 or 2.6 if it rounds up. Now, next to the 5 is a 6. Because 6 is 5 or more, this 5 will round up to 2.6. And so finally, the value of x to 1 decimal place is 2.6 centimeters. You need to recognize this triangle here is similar to this one over here, but 4 times bigger. 0.64 times 4, that's the key to finding out the solution. Here we are, the very last question, and suitably it's quite the beast. So let's read it carefully. ABCH is a square. And so what does it mean by ABCH? It means the shape that goes from A to B to C to H. And so I'm just going to colour in yellow what ABCH is. So it's this top square. We're then told that HCFG is a rectangle. HCFG is this shape here. And the last thing we're told is CDEF is a square. So this bottom shape, bottom right, is a square. Like so. Now we need to show that the total area of all of this L shape in centimeters squared is x squared plus 9x plus 27. Wow. It is possible, just need to take our time and not panic. First of all, squares. What's special about the sides of the square? If you think about a square, each side of a square is the same length. And so for this one here, if this is x plus 3, or long, it's also going to be x plus 3 high. And this square here, if this one's 3, then it'll also be 3 centimeters long. Finally, this green bit, because the square is x plus 3 across, it'll be the same for this rectangle as well. So the rectangle will be x plus 3 in this direction too, and the height of it will be the same as this square. This square is 3 high, so this rectangle will also be 3 high, or 3 wide, depending on how you want to think about it. So we're on about the area. How do you calculate the area of a square or a rectangle? Well, you take the length and multiply it by the width. So what I'm going to suggest we do is take it step by step. And so the area for ABCH, first of all, is going to be the length times the width. But for a square, the length and the width is the same thing. So for ABCH, the length is x plus 3, and the width is also x plus 3. And so it's a case of expanding the quadratic x plus 3 multiplied by x plus 3. This is what we're doing here using this grid method. So what we're going to have is 4 different things to work out when we expand it. So x times x gives us x squared. This one over here, x times 3 is 3x. Over here, we've got x above, 3 to the side. X times 3 again is 3x. And finally in this box, 3 multiplied by 3 gives us 9. And so if we just simplify all this down, we've got 1x squared. How many x's do we have? We've got 3 x's here, plus another 3 x's here. That gives us 6 x's in total, and plus 9. And so the area of ABCH is x squared plus 6x plus 9. And so if nothing else, we've got some marks for working out the area of ABCH, which is this one. Now, after that, we can work out the area of HCFG. And so for HCFG, the area is the length of it times the width. So 3 multiplied by x plus 3. Now we just need to expand out the brackets. One times the other, just multiply it out. So first of all, 3 times x, and then 3 times 3. 3 times x gives us 3x, and 3 times 3 gives us 9. And so for the green rectangle, HCFG, the area of that is 3x plus 9. And finally, the square is CDEF. That's the easiest one to work out because it doesn't involve any algebra, thankfully. Just numbers. It's 3 by 3. So the area of this square is just 3 times 3, which is 9. So we can put all this together now. This bit is x squared plus 6x plus 9. This bit's 3x plus 9. And CDEF is just 9. So the total area is going to be x squared plus 6x plus 9, which is just what ABCH is, plus the green bit, which is 3x plus 9, finally plus the area of a little blue square, CDEF, EF at the end, which is just plus 9. So we've got three different things to group together. We've got x squareds. Now I've only got one x squared. How many x's do we have? We've got 6x's over here, plus an extra 3x's over here. 6x plus 3x gives us 9x. And then the units, we've got plus 9, plus 9, plus 9. 9 add 9 add 9 is a total of adding 27. And so that all simplifies down to give us x squared plus 9x plus 27, which is what we wanted to prove in the first place. So we've proven using algebra that the total area of all this shape is x squared plus 9x plus 27. That's the final question, which was quite hard, as I'm sure you'd agree, but it is possible step by step. Anyway, thanks for listening and good luck with your exams.